In 2026, the P-800 Oniks, also known internationally as the Yakhont, continues to evolve into one of the most advanced supersonic anti-ship cruise missiles in service. Originally designed as a high-speed sea-skimming strike weapon, the Oniks has undergone several upgrades over the years, but its 2026 modernization brings a significant shift in capability and strategic relevance. Despite being part of an older missile family, its ability to adapt to modern requirements keeps it active across multiple naval platforms and coastal defense systems. The Oniks was originally built to overcome the challenges of naval warfare, specifically the rising sophistication of surface-to-air defenses and shipborne radars. Its defining trait has always been its speed. With the ability to fly at nearly Mach 2,5, it remains faster than many subsonic cruise missiles still in service around the world. But speed alone is no longer enough. Modern warships rely on advanced sensors, electronic warfare suites, and layered defense networks. That's why the 2026 Oniks upgrade focuses on intelligence, survivability, and precision. One of the biggest changes in the 2026 model is the updated onboard seeker system. Earlier versions used an active radar seeker with limited filtering capability. The new upgrade introduces an enhanced multi-band seeker with improved resistance to jamming, better target recognition, and faster processing. This allows the missile to maintain lock even in environments filled with electronic interference. The seeker can now differentiate between decoys, drones, and the actual targets, making it far more reliable in complex combat conditions. The 2026 Oniks also receives enhancements to its navigation system. Instead of relying solely on inertial guidance and radar homing, the new version integrates satellite navigation support and the updated terrain matching software for overland flight patterns. This expands its utility beyond purely maritime roles. In previous decades, the Oniks was primarily a ship killer. Now, it can be used against coastal infrastructure, radar stations, and strategic land targets with greater precision and flexibility. Another key change is the improved engine performance. Engineers have modified the solid fuel booster and the ramjet propulsion system to increase fuel efficiency and stability. As a result, the missile's effective combat range has been extended, giving it a broader engagement envelope. This upgrade enables platforms like the Bastion P coastal defense system to strike targets even deeper into hostile waters or along complex coastlines. For naval vessels, this means longer-range offensive capability without needing to close the distance to enemy fleets. The missile's flight profile has also received refinements. Traditional anti-ship missiles often follow predictable routes that can be tracked by modern radars. The updated Oniks incorporates adaptive flight behavior, allowing it to make unpredictable altitude and direction changes during the terminal phase. It can switch between high-altitude cruise for maximum range and low-altitude sea-skimming to reduce its radar signature. These rapid maneuvers complicate interception efforts, forcing defensive systems to adjust constantly. Another improvement is its upgraded communication link. The 2026 Oniks can receive mid-course updates from launch platforms or command units, enabling it to target or adjust routes in real time. This is especially useful in naval environments, where targets often change direction or speed. Ships rarely remain stationary, and the ability to adapt mid-flight increases the missile's chances of striking moving vessels accurately. Even though the missile is fast and powerful, its designers have also focused on improving its survivability. The 2026 upgrade includes low observable features in the missile's structure and decoding. New composite materials help reduce radar cross-section, making detection harder during the mid-flight phase. Combined with its sea-skimming behavior, this gives the missile a better chance of approaching enemy ships before sensors pick it up. Warheads also benefit from modernization. The new Oniks maintains its traditional fragmentation high-explosive design but adds improved penetration characteristics and optimized blast patterns. This means the missile can deal more effective damage even to ships with hardened hulls, advanced compartmentalization, and reinforced decks. The warhead is engineered to maximize internal destruction, increasing its impact against both large and medium-sized naval vessels. Deployment versatility remains a major strength of the P-800 family. The 2026 upgrade is compatible with a wide range of platforms including surface ships, submarines, coastal launchers, and mobile ground units. This flexibility ensures it can be strategically positioned across different theaters, extending operational utility and allowing rapid response in evolving maritime scenarios. The missile's modular architecture also simplifies integration with modern fire control systems. Another area of improvement is mission planning. The 2026 Oniks can be part of coordinated swarm-style attacks where multiple missiles collaborate by sharing targeting data and dividing engagement roles. In such missions, one missile may rise to higher altitude to act as a scout while others remain low. This distribution helps the group avoid incoming defenses, overwhelm radar systems, and increase strike probability. Although the missile's core design dates back to earlier decades, the 2026 upgrade shows how older platforms can remain relevant with digital modernization. The combination of faster processors, improved sensors, more efficient propulsion, and the smarter guidance systems gives the Oniks capabilities closer to those of next-generation anti-ship missiles. But its role is not purely offensive. The presence of such a missile in coastal defense systems can affect regional naval strategy, influencing how rival fleets move or deploy assets. The upgraded Oniks contributes to deterrence by complicating opponent planning and forcing them to invest in better defenses, counter-jamming equipment, and evasive tactics. As global naval competition increases, the modernization of legacy systems like the P-800 Oniks highlights a broader trend. Nations are extending the life of proven missile families by integrating software upgrades, advanced electronics, and modern propulsion improvements. By doing so, they maintain capability without developing entirely new systems from scratch. This approach allows for quicker production cycles, lower costs, and faster deployment. The Oniks may not rely on hypersonic speeds or revolutionary propulsion, but its combination of reliability, speed, electronic resilience, improved accuracy, and the extended range keeps it relevant in 2026. It shows how incremental technological upgrades can transform an aging system into a modern weapon suited for contemporary challenges. For analysts and the observers, the 2026 version of the P-800 Oniks represents a balanced mix of proven performance and the modern adaptation. Its evolution reflects how missile technology continues to expand through smart updates rather than dramatic reinventions. As long as naval threats continue to evolve, systems like the Oniks will continue receiving upgrades that help them meet the demands of new battlefields and the new strategic realities.